Hello and welcome to today's physics class. We'll look at the concept of optics in physics. So let's define optics and look at several important things to note in the study of optics, and also we'll look at the branches of optics. After then, we'll solve several past questions in the study of optics. So first things first, what is optics by definition? Optics is the study of light. So basically, optics has to do with the study of light. So the study of light refers to as optics. Optics is simply the study of light. Please note, light ray and wave are electromagnetic in nature. Light ray and waves are electromagnetic in nature. They have the same velocity but differ only in wavelength and frequency. I said light ray and wave are electromagnetic in nature. They have the same velocity but differ only in wavelength and frequency. One line space paragraph, please. One line space paragraph. The speed in bracket v, the speed in bracket v, frequency in bracket f, I said the speed in bracket v, comma, frequency in bracket f, and wavelength in bracket your lambda. All right, and wavelength in bracket lambda of an electromagnetic are related by the formula of an electromagnetic wave are related by the formula. All right, V is equal to F lambda. All right, so have this, please. So here's the idea. The relationship between velocity, frequency, and wavelength is this: that the velocity will be equal to the product of frequency and wavelength. Now, this is velocity. Now, listen, this is what the velocity. But I said of an electromagnetic wave. Now, for an electromagnetic wave, we will not use V, we will use C. And why are we using C? Let's move forward, please. I will explain why we use C. Now, there is one question I came across online that says something like this: how is light different from other electromagnetic wave? I think that's how it comes. So how is light different from electromagnetic wave? So here's the stuff to note, right? So note this down, please. Note this key concept down, please. Note electromagnetic wave moves in a speed of light. Electromagnetic wave moves in a speed of light. And speed of light, of course, speed of light, of course, that's C. So for an electromagnetic wave, we said the electromagnetic wave moves like what there? A speed of light. And speed of light has a symbol C. So in other words, for a proper writing, and by the way, please, the speed of light has a constant value, and the speed of light C is given by 3 times 10 to the power 10 to the power 8 meter per second. This is the highest speed discovered by man so far on the Earth's surface. So that C, speed of light, is equal to 3 times 10 to the power 8 Newton per meter per second, right? So this is the highest speed discovered by man on the Earth's surface, right? So we said for an electromagnetic wave that both the light and the electromagnetic wave travels like the speed of light. So it means that if I want to write my relationship, I won't write V. So in terms of electromagnetic, so in terms of electromagnetic wave, my expression becomes not V now, becomes what the C, becomes a C and light speed, obviously. So we said light wave and electromagnetic wave travel at the speed of light. So I'm saying that C will become the word there, F, and you have your lambda. So in terms of electromagnetic wave, C is speed of light will be equal to what the F lambda, right? So this is how this concept works. And we said, here's the thing, please. Let's say you're in an exam or you are asked to find frequency. They give you a task in class or in exam or to find frequency, and you are given only the value of wavelength. So here's the task here. You can't find two or none at the same time. But here's the task here. If you are asked to find frequency and you are given wavelength only, here's the task here. They expect you should know that C is speed of light. And speed of light is what the 3 times per what 8 meter per second. So bear in mind, it might be given, it might not be given. So bear in mind, the way you know the value of pi is 20 over 7 or 3.142. The way you know gravity 9.81. That's how you know, you should take this in mind too. So the way you know those stuff there as constant stuff there, that's how you should know that the speed of light C is also constant, and that's the value of 3 times per 8 meter per second as shown on the board here. And let me just take you to a real life experience of this concept here, right? So if you check your thunderstorm, right, when thunder, happens, there are two things that take off immediately, right? Because usually when you get thunderstorm, there are two things you usually experience. You see a light, that's lightning, and you hear the thunderstorm sound, right? So that's like the combination of what light wave and sound wave, right? So if you check properly, the lighting comes first before the sound, right? So whenever you see lightning, you should expect that you hear biri 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 ba. That's like the thunderstorm there. The sound follows. So here's the technique there. The speed of light is so powerful enough to move faster than the sound wave. The two of them are released at the same time, but light wave cannot wait enough for sound. So the light comes first, followed by what the sound wave. That's like the idea behind speed of light faster than electromagnetic wave, and that's like concept behind this stuff here. At this junction, at this junction, let's look at the branches of optics, right? Branches of optics, right? Right. Branches of optics. Put on please. There are two main branches of optics. There are two main branches of optics, which include, I said there are two main branches of optics, which include number one, we have the geometric, geometrical optics. Number two, there we have physical optics. Optics. All right. So what I will do here is this. I won't waste much time. I'll just touch the two of them and look at what they mean and then move on, please. Look at the first one there. Let's look at the first one there called um, geometric geometrical optics. All right. So let's explain what geometrical optics means, and let's see what it entails. Right? Put down, please. Put it down, please. Under geometrical optics, put it down, please. The ray treatment of light is called geometrical optics. That's all. The ray treatment of light is called geometrical optics. Full stop, please. It deals with rays, RAYS on the screen. It deals with the rays. Alright guys. So if I'm to ask you, you have been hearing ray, not now, right? Because I've done videos on what's it called there? What's this stuff called? Wave. Yes, we have looked at wave very well. Type of wave, classification of waves. We have done waves. We've looked at light wave, right? Reflection, refraction, interference. Understand those concepts there. This is not the first time you're hearing ray. So what's a ray? I have to ask you, what's a ray? You can pause the video and reflect. Or you can leave your answer in the comment section. What's a ray? So I'll define it, but don't use my definition. So give me your definition. What's a ray? To save time, let's define it, please. Definition, please. What's a ray? A ray is simply the path. A ray is simply the path along which light energy travels. A ray is simply the path along which light energy travels. All right, so stop. It can also be defined as the motion of stream of particle. It can also be defined as the motion of a stream of particle in brackets photon in brackets photon. The spelling on the screen, please. In brackets photon, emanating from a source. Full stop. Emanating from a source. So I'm saying this, that a ray is simply a path along which light energy travels. That's all. That's a ray, right? So a path that allows light energy to travel is called a ray. How would please? At this junction, please. At this junction, please. Note. Please note. I'm just focusing on the key ideas you need in those thoughts. I don't want to give you much more notes take home. Just the key and the important concept to note in those things, and then we'll move on, please. Note, please. Many experiments in geometrical optics requires the location of the image. I said many experiments in geometrical optics requires the location of the image of an object, comma. One method of doing this is the use of pin. One method of doing this is the use of pin, called the method of no parallax. Called the method of no parallax. Now, if you check properly, you know what I'm saying is on the screen. In case you can't hear my accent or you mistakenly hear me wrong, the spellings, the word for word, everything is on the screen. So take your time, pause the video and write them out before you move on. Now I'm saying this, please. If you check properly, some people will get to know what I'm trying to say here. Now when I get to one method of doing this is the use of pin, called the method of no parallax. Some people will understand what I'm trying to say there. If you go back to SS3, when you're doing your practical there, you go to the physics lab, you see there are several glasses there. You see rectangular prism, triangular prism, and then you'll be seeing, this kind of practical you did that time, you put a pin, and then from that pin, you now try to check inside the pin to spot out where the other pin will be. That stuff there is called the method of no parallax. Either I use rectangular prism or triangular prism there. You will put a pin and then only God knows what you're looking for, right? So that stuff there, that particular stuff there is called the methods of no parallax. So that's like the idea behind. Some people can relate, some cannot relate. Anyways, move on, please. So that's like the idea behind the method. So in a case whereby you're in exam hall, you're now asked, what does parallax means? Method of no parallax means. You know what it means. So, right? The process of using pin is called the method of what there no parallax. At this junction, please, put on please. The advantage of this method is that the position of the object and image. The advantage of this method is that the position of the object and image can be found in a greater precision of measurement. Can be found in a greater precision of measurement. Oh, stop. Okay. Okay. Now, let me take you back to this place. If you were familiar very well, like literally in your school, you did this practical. Obviously, in this century we have, there's not anybody that knows this practical, even chemistry practical. Most schools don't take students, right? And they will find their exam, in their exam curriculum, they have to do practical. So some students find it difficult, to get to know what this practical means, right? So, but that's by the way, please. I'm going to this place. Those that have experience about practical sections, right, in your school, in your practical section very well. There's a manual they'll give you to fill every time. You after every experiment, you fill a manual, right? So that manual, there's some you will see that they'll ask you for the precaution you took for that particular experiment to be successful. You know, I ensure that, but for if you remember, for this prism, triangular prism, the first thing you write there is called I avoiding mistake or something there due to parallax. I avoid a mistake due to parallax. The word parallax there, what does it mean? For that I've done particle section under this prism, this concept there, you'll be familiar with the word parallax. So what's a parallax? What's a parallax? What does it mean? Right? What's a parallax? We said I avoid error due to parallax. Right? That's your first precaution. So what is that parallax? What does it mean? What's parallax? Think. What's the parallax? What's parallax? Parallax. Okay. Definition, please. Put it down, please. The motion of one object. Put it down, please. Let's define parallax. I said this is the motion of one object relative to another object. The motion of one object relative to another object is called parallax. Please, it is called parallax. Please, don't forget. Please, that's like the idea behind parallax. So the motion of one object relative to another object is called no parallax. All right, comma please. Which is eliminated by making the object which is related, which is eliminated, please, by making the object concealed with its image. By making the object concealed with its image. That's how you define a parallax, right? So here's the tag, please. if you check the first thing I gave you under geometrical optics, I said it is the, what I say? I said geometrical optics is the ray of speed of light. Geometrical optics is the ray speed of light. So if you refer back to geometrical optics, right? I said it is the ray treatment of light. If you check your notes, check the first statement I made when I gave you when I started with geometrical optics. I said it's the ray treatment of light, right? So here's where I'm going. Put this down, please. Put this down, please. Put this down, please. Copy down. The ray treatment of light. The ray treatment of light include the ray treatment of light include number one, rectangular. Okay, sorry, rectilinear, please. Rectilinear propagation of light. Number one. Number two, the laws of reflection. Number three, there, the law of refraction. The law of refraction. All right. These are the three ways to which you can treat light, right? So geometrical optics is the ray of light, and the ray of light include number one, rectilinear progression of light. Number two, the law of reflection, and number three, the law of refraction. Now, I have done a full tutorial video on the law of refraction and the law of reflection and refraction. Please, I will leave the two video link in the video description, or you can go to my playlist, right? My physics tutorial playlist. Check there and scroll down, like check the topic. You will see wave. After wave there, I dealt with these two stuff there, law of reflection and refraction. So go after this class. You're not done watching. You're not done with this concept there. So go and watch video on these two. Link to these two classes will be displayed in a video description. So check description properly so you can see the link directly. Or better still, go to my playlist and check for physics full course, right? That's the name I gave it. Physics full course, right? Just check physics full course and scroll down. You see many topics I've covered in physics, and basically they are all arranged. So go and check for wave. Under wave, you see these two stuff there I have dealt with, right? That's by the way. All right. So at this junction here, um, before we leave this class, I said you should go and watch these two. They are available. What of this first one? All right. Let me just take you through this first one and let's see what it means. So number one, then let's explain rectilinear propagation of light is propagation of light. All right. Rectilinear propagation of light. What does it mean? Now, I'll try to explain this using what we have been watching so far in movie, right? Something like the American Soldier movie. If you're familiar with that kind of movie, I don't really like it, but there's something to take out from that concept. So there's a way they use this particular stuff in war, right? So to explain this better, there's a way American Soldier movie they apply this thing there. It's called what's it called there? It's called periscope. Is it periscope? Um, yes, periscope. Yes. The idea of periscope works with rectilinear version of light. That's the key. So the idea of periscope works with this particular concept. And what's a periscope? How does it work? Now, before I move on to explaining in full detail, giving you examples, real life examples of this concept there, let's do definition. What is rectilinear version of light? Put on please. This is the process by which light travels in a straight line. This is a process by which light travels in a straight line. Please. This is a process by which light travels in a straight line. Say it after me, please. Say it after me. This is a process by which light travels in a straight line. Don't forget, rectilinear propagation of light. The word rectilinear, if you are familiar with physics term, rectilinear means something straight, right? Propagation is being shot out of light. So when you have light being shot out in a straight format, it's called rectilinear propagation of light. That's how you define this concept. Now I'm saying this, please. I'll give you two life scenario of this concept. The first one there is touch. If you have a torchlight, if I on my torchlight and point it here, my light will travel in that direction. So if I on torchlight here, it can't be showing here. No, that's not possible, right? In that case, it's no more torchlight. You know, becomes evil light, because if I can on touch here and it's showing here, something is wrong somewhere. And I think I have to run away, because obviously it's not readable. I cannot just happen. Understand? But if it happens, please run away. So you're having a torchlight here. Your torchlight is meant to focus on that particular direction you are pointing it to. That's the concept there. So a torchlight is an atypical example of what there of rectilinear propagation of light. A straight, that's the place. That's torchlight case. Now the case 2 is what I'm talking about, which is called the periscope, right? A periscope. See the spelling of periscope in the screen, please. Now, here's a tag, please. What's a periscope? How does it work? How can we relate rectilinear propagation of light with a periscope? So look up, please. Let me just try to I'm just trying to explain. Let me just draw some diagram to explain what I'm saying here. So a periscope is what this American soldier uses, to sight the enemy from a ditch. What's a ditch? I'll show you what I'm saying now. I'm coming. Right, coming. Okay. So let's say I have enemy here. So an enemy is here with a gun, right? And I have, observe please, this is called a ditch. Right? So let's say an enemy is far from, this is just closer, but let's say it's far, right? The enemy is far from this place here. A soldier will be here under the ground, right? So there's a device called periscope. It looks like this. It's like a glass, a mirror, right? That allows you to see. You should know this very well. What I'm drawing. You should know about this very well. Let me just draw it so that you can relate. Come. So people should have known what I'm saying here, right? So I'm not saying it's big like this, but I just want to draw it so that you can understand the idea behind this. So what is here is a mirror, right? What is here too is also a mirror. Are we good, guys? A mirror, right? So I have two mirror here. Now, please, here's what these two mirror are doing. I have my sun here. I have my sun here. My sun here. When my sun hit, when this sun, not my sun, please, when this sun hit this soldier here, this soldier When the sun hit the soldier, there will be a light that will be transferred. The light will what? Refract back, right? To this. The light comes here and bounce out to this. And that light will enter this glass, right? This glass that is here will now reflect what is seen down here, right? This glass here will now reflect what is seen down here, such that the soldier that is under this ditch can easily see the person that is here. So if you observe the rectilinear way to which that stuff is moving, straight this way, straight down way, and straight down here, this is called a typical what there example of a rectilinear motion of light. I think I will try to get an image, or I'll play a clip of video if I can make the research. So you watch this, you see it on the screen. If I make the research, you see it. If I don't make the research, you won't see it. But understand what I'm saying here, that the sun reflects to this man, right? Why that sun that is reflecting to this man will be transferred straight this way, and this way here, the light will hit this mirror, so that this mirror will now reflect what is seen to this other mirror, right? And this other mirror here will allow the soldier down here to easily see who is up here. All this stuff are done using what? All this idea are idea behind, or are idea of rectilinear direction of light. So this is how the concept this works. So I said these other two, I will not explain them here. I have done videos on them. So go and watch the videos. I'll leave a link to those two videos in the video description. So do want to watch them and leave a comment, like and share this video. Please, if you're a student, don't be stingy, right? This video just watch finish. You know in your heart that there's some of your classmates, your classmates that don't know these things. Do well. You see a share button, your class group, your department group. Please share this video. As you are sharing it, there will be a blessing unto you, right? Yes, a reward will be unto you. So me doing the video, I have my own reward. You sharing your video to other people, you have your own reward too. So don't be selfish in quote. Whatever you learn, try to share with others. So I'm saying this, please. When you're done watching this video, just you will see a share icon. Go there and share it to all your platforms, guys. So this is one video that I think is very interesting. You can watch it out. It's break a lot of things down. It is, and please, why share my videos or anybody's video to WhatsApp? When you copy the link on YouTube, most of you have had the experience of when you put the link on your WhatsApp key box and you send it, it will not show the person image design, things like that. It will just send link. What you are sending, here's what to do, please. When you click on WhatsApp, you copy the link on YouTube, paste it on that box and wait a while. When you wait a while, it will load. It will bring out the person picture, the thumbnail of that particular video. And when you send it, it is easier to read than you giving a description about the video. Just copy the link, paste on YouTube, paste it on WhatsApp. When you paste on WhatsApp, wait a little bit. If you have a strong network, that link will load. When it's not finished, they can send it. Then without telling anybody anything, they can read, they can see what they want to see, right? Instead of sending the link and description down, which is fine. I think that method will be okay for you, right? So that's like the idea behind this concept. So see you guys in this class and welcome to Excellent Link Academy. So what again? So if your first time here, please guys, do subscribe to this channel. We are family, right? Subscribe to the channel, leave likes, leave comments, share to your friends and classmates. At the same time, do well to join our WhatsApp community. So the link to our WhatsApp community is in the description. So in the description, you see a link to our WhatsApp community, WhatsApp group, my Facebook page, Instagram page, and every other page is there. They are on this channel. So do well to follow us there See you guys in the next class, and welcome to Excellent Link Academy. 36.